everyone.
Good morning, ma'am.
Today we will learn how to write chemical formula of substances of compounds. Okay? So here, what is chemical formula? Define chemical formula. Yes? Chemical formula. Yes.
Ma'am, writing the formula of a compound using the symbols of the elements.
Very good. Writing of using the symbols, we write the formula of a compound. Writing of these. Okay, this is the representation of the compound using symbols and using symbols. Okay. So, what are ions? This is the previous knowledge. What are ions? What are ions? Radicals. Yes. Ions. G. Yes. Yes. Yeah, like positive or negative charge. Yes, the positively or negatively charged particles, है ना? These are called ions. They are simply atoms which contain some charge. Okay, which have some charge. So there are two types of ions we have read already in the previous classes. Ions are of two types. That are cations. Which charge do they have? Positive. And anions. Negatively charged particles. Okay, these are negatively charged particles. Anions. Give some examples of cations. Please raise your hand. Those who wanted to answer. Yes. Cations. Give two examples. Zinc. Yes. Calcium. Yes. Very good. So Zn2+. This is having charge. Positive charge. Calcium. There are many examples. Sodium. These particles. These are the particles that carry positive charge. Now anions. These are examples of anions. Yes. Yes, please.
Sulfate,
Sulfate. Formula. Say the
SO4,
symbol of sulfate ion.
SO4 2 minus.
SO4 charge 2 minus.
Chloride, bromide, chloride.
Yes, bromide, chloride. Yes. Yes.
Hydroxide.
Hydroxide, OH minus. There are many examples. These are the negatively charged particles. We also call these anions. Okay. So our next is we will learn today how to write chemical formulas. Okay. So first of all, what do we do? Suppose I give you 2-3 examples. The rules are we will write the name of the compound whose name we want to write, and then we will write their symbols. Okay. Take for example like potassium chloride. Potassium chloride. Now tell me what is the symbol of potassium ion? K charge plus 1. Okay. Chloride ion? Minus 1. Okay, so next thing is we will write their charges just below the symbol. Here again we will do the same. And what we will do? We will do crisscross multiplication. Okay. Now K is multiplied with what? K is multiplied with 1. So it is K1 and Cl is multiplied with 1. So the formula of potassium chloride is KCl. Can we ignore 1?
Yes.
So the formula of potassium chloride is KCl. Now, see the next example. Calcium carbonate. Tell me the symbol of calcium ion. Ca charge 2+. Carbonate ion. Yes, we will write their valences charges just below the symbol. 2, here again 2. Okay, so these are common now. Can we cut it?
Yes.
2 ones are 2, 2 ones are 2. Now what we will do? Crisscross. Crisscross. We will multiply. Cl multiplied with 1. Cl 1. And CO3 multiplied with 1. CO3 whole 1. Or we can we ignore 1 here? Anything multiplied with 1? It gets the same. Air charge? Liters. Bromide ion? Br charge? 1 minus. Yes. So you write their charges just below it. 3, here, 1. And then what do? We will do crisscross, cross multiplication. Here Al 1 and Br 3. Can we note this one? Yes. Now it is Al Br 3. Okay. Now see this. Watch this video.
Just as you can write your name in short form using your initials, the names of elements are written using symbols. The symbol is the first letter or the first two letters of the element's name, or the first letter and another letter of the element's name. The first letter of a symbol is always a capital letter, while the second letter, if there is one, is always a smaller letter. The symbols for some of the elements are derived from the element names in Latin, Greek or German. For example, the symbol for iron, Fe, comes from iron's Latin name, ferrum. The symbol for tungsten is W, from the German word Wolfram. The names for all newly discovered elements are now approved by the International Union for Pure and Applied Chemistry, the world body that standardizes naming of elements, compounds, and so on. The chemical formula of a compound indicates the number of atoms of each element that is present in the compound. The symbols of elements are used to write the chemical formulae. Here, you will see how to write the chemical formulae of some compounds. First, let us take the example of the ionic compound aluminium oxide. Aluminium oxide consists of aluminium, a metal, and oxygen, a nonmetal. The symbol of aluminium is Al. The symbol of oxygen is O. When writing the chemical formula of a compound, the symbol of the metal is written first. The aluminium ion has a charge of +3, and the oxide ions have a charge of -2. Interchange the numerical values of the charges. Next, indicate the interchanged values as subscripts of the symbols. In a chemical formula, we do not indicate the charges on the ion. So, the formula of aluminium oxide is Al2O3.
See one more example.
Now, let us take the example of sodium chloride. Sodium chloride consists of a sodium ion and a chloride ion. The charge on the sodium ion is +1. The charge on the chloride ion is -1. Let us interchange the charges and indicate them as subscripts of the symbols. When writing chemical formula, if the valency is 1, we do not write the number 1 as a subscript. So, the formula of sodium chloride is written like this.
We will watch some more examples.
Writing chemical formulae. Dear students, a compound is made up of elements. Each element has a specific symbol. These symbols are used to derive chemical formula. A chemical formula is symbolic representation of chemical compound. For writing a chemical formula, it it is necessary to know the valency of the elements. Valency is capacity of particular element to combine with other element to form a compound. For example, carbon can combine with maximum 4 atoms. Hence, valency of carbon is 4. Similarly, valency of potassium is 1, calcium is 2, etc. So let's see the notes for writing chemical formula for compounds. Rules for writing chemical formula for binary compounds. Binary compounds are made up of 2 different elements. Hence, to derive chemical formula, we write elements with their valencies. After this, cross over these valencies to balance formula. Write valencies as a subscript. A subscript is a character written slightly below the another character. Here you get formula for the chemical compound. For ionic compound, ionic compounds are made up of metal and non-metals, which are in the form of cation and anion respectively. To write formula for ionic compounds, symbol of cation is written previous to symbol of anion, and charges of ions should be written below them. Now cross over the charges of ion to obtain the chemical formula of compound. If charges of ions are same, then neglect the subscript in the formula. For more than one similar groups, arrange elements or ions and their valencies or charges using previous process. Here, OH ion is polyatomic, which occurs twice. Hence, it should be included within the brackets. Write the charges as a subscript outside bracket. If there is only one group of polyatomic ion, then neglect the brackets. Now can we write chemical formula for ammonium sulfate?
Yes. This is the chemical.
I hope you understood this topic. Thanks for watching this video.
Watch the more video.
Formulae. The chemical formula of a compound is a symbolic representation of its composition. The chemical formulae of different compounds can be written easily, but for this, we should know the symbols and their combining capacity. We have studied symbols of elements. Let us now learn about the combining capacity of elements. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. Let us understand valency by an example. Imagine if an octopus is to hold some humans in such a way that its 8 arms are used with both arms of humans, how many humans can an octopus hold? If we represent octopus as O and humans with H symbols, can you write a formula for this combination? The octopus can hold up to 4 humans. Therefore, we can write its formula as OH4, where 4 represents the number of humans captured by the octopus. Here, you can see the valencies of some simple and polyatomic ions. Let us now look at the rules for writing chemical formulae. 1. The valencies or charges on the ion must balance. For example, the formula of hydrochloric acid compound is HCl, where the valency of both hydrogen H plus and chlorine Cl minus is 1, which is balanced in this formula. 2. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide, CaO, where oxygen is non-metal and is written on the right, whereas calcium is metal and is written on the left. 3. In compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. For example, the formula for ammonium sulfate is NH4 2SO4. Here, the number of polyatomic ions ammonium NH4 plus is 2. So, we write it in a bracket. Similarly, if the number of polyatomic ions is 1, such as sodium hydroxide, NaOH, bracket is not needed here. Let us now practice writing.
Now, I have brought a dice for you all. This is a dice containing all the cations, many cations, 6 cations in this dice. You have iron, Fe3+, aluminium, zinc, calcium, many, 6. And in this one, this is a dice of anions. Okay, now we will play a game. I am going to roll this dice. Let's see what will come. Okay, this is a dice. Okay. So in this dice I have got Zn2 plus and in this one I have got OH. So let's write its name, chemical name. Zinc. This is zinc hydroxide. What I have got in this cation dice? Zinc. Zn2. In an iron dice I have got let's write its chemical form. Okay, so what should I write here? 2 and here 1. Okay, now what I will do? Trace cross multiplication. The Z is multiplied with 1 and OH multiplied with 2. So the formula of zinc hydroxide is ZnOH twice. Okay, now who wants to play this game? Yes, come. Roll this dice. Yes, she got in this one in cation she got Fe3 plus and in anion she got Cl minus. Okay, right. Iron chloride. Iron chloride. What is the valency of iron here? Say. 3. Symbol is Fe3 plus. And what is the chloride? Symbol of chloride iron? Cl. Charge 1 minus. So we will write their valencies just below the symbol and then crisscross multiplication. The formula of iron chloride is FeCl3. Very good. Who wants to come next? Yes, come. Roll the dice. Yes, she got magnesium and in the anion she got SO3 Magnesium sulfide. ITE. Magnesium sulfide. SULPHIDE. Yes. Symbol of magnesium. What it is? Mg. 2 plus. And in sulfide. SO3 charge. 2 minus. So again here there is a common valencies, isn't it? 2 and 2. Can we cut these two?
Yes, ma'am.
2 ones are 2, 2 ones are 2. So now the formula of magnesium sulfide is MgSO3. Okay, who want to come next? Who want to come next? Yes, come beta. Roll the dice. What it is? In the cation box, he got Na plus sodium, and in this sulfide again. Okay, very good. Write the name. Number 4, yes, sodium sulfide. Very good. So you learned how to write chemical formula?
Yes, ma'am.
Yes, very good. Na plus and formula of sulfide? SO3 charge 2 minus. Yes. So valency of sodium is 1 here. 1 and here 2. We will write the formula, the valency charge is just below it. Okay? Here, right here 1 and here 2. We will write with the charges now. Just below this. Yes, now do this. Correct. Do this. Who want to come next? Yes, come. Very good. Roll the dice. Yes, she got in the cation. She got yes. This is very good. She got in the cation. She got zinc, and in anion she got phosphate. Okay. Write the name first of all. Zinc phosphate. Formula of zinc ion